Questions 1 through 10 on the 2004 Grade 10 AMC 10-8. You and 5 friends need to raise $1,500 in donations for a charity, dividing the fundraising equally. How many dollars will each of you need to raise? So there's $1,500 that needs to be raised, and there's you and 5 friends, so that's a total of 6 people. And each of you have to come up with an equal amount. So 1,500 divided by 6 should give you the value, and that is equal to $250. So each person has to raise $250 in order for those 6 people to come up with a total of $1,500. So number 1, the answer is A. For any 3 real numbers A, B, and C, with B not equal to C, the operation symbol is defined by symbol of ABC is A over B minus C. What is the value of this long expression? So it looks like they've got a symbol here, a symbol here, and a symbol here. And then once you figure that out, you're going to do it once more. So let's first figure out each of these individually. So let's first look at that. So I've got this strange symbol 1, 2, 3. Now, they give you the definition of that up there. It would be A over B minus C. So this is A, this is B, this is C. So it would be A over B minus C. So this looks like 1 over negative 1, which is negative 1. Now let's do the same with the second one. The symbol of 2, 3, 1 would be A over B minus C, which is 2 over 3 minus 1, which is 2 over 2, which is equal to 1. Right, no problem so far. And then let's do the third one. The symbol of 3, 1, 2 is A over B minus C. We got 3 over 1 minus 2, which is 3 over negative 1, which is negative 3. So this basically now becomes the symbol of negative 1, 1, and negative 3, like that. And then we apply our operation once more, and we'll get negative 1 over 1 minus 3, like that. So negative 1 over 4. And that's it. So number 2, the answer is B. Alicia earns $20 per hour, of which 1.45% is deducted to pay local taxes. How many cents per hour of Alicia's wages are used to pay local taxes? So $20 and then 1.45%. So you have to divide that by 100 to get a decimal value. And that will be basically 0.0145, like that. So then you take that and you multiply that by $20, 0.0145, and this will give you the actual amount. And that looks like 0.29. And $0.29. And that is the equivalent of 29 cents. And let's see, the answer choices, how many cents? Okay, so they do indeed have it in cents. And we have 29 cents. So number 3, the answer is E. What is the value of the absolute value of x minus 1 equals absolute value of x minus 2? What is the value of x? All right, so we've got absolute value, so we'll probably have a few scenarios here. The first scenario is when x is greater than 2. That will make that positive. The next is when x is less than 1. That would make this guy negative, and then when you take the absolute value, it will be positive as always. And then of course the third scenario is when when x is between 1 and 2, like that. Less than 2 but greater than 1. So for each of these, let's see what we get. When x is greater than 2, the first expression becomes just x minus 1, and the second one becomes x minus 2. So that means minus 1 is equal to minus 2, right? Because the x's cancel. Well, obviously that's not possible, so this doesn't give me any solutions. All right, let's turn our attention to when x is between 1 and 2. The first one would give me x minus 1, and the second expression will give me minus x minus 2, like that. So x minus 1 is equal to minus x plus 2, and bring the x over, you get 2x is equal to 3, and therefore x is equal to 3 over 2. All right, just for the sake of completion, let's do this one, x less than minus 1. When x is less than minus 1, you get minus x minus 1 is equal to minus x minus 2, like that. So the negatives cancel and we get x minus 1 is equal to x minus 2, and this is the same scenario as before where this gives us no solutions. So the only solution we got was x equal to 3 over 2, and therefore number 4, the answer is D. A set of 3 points is chosen randomly from the grid shown. Each 3-point set has the same probability of being chosen. What is the probability that the points lie on the same straight line? So let's label these 9 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. And we want to choose three of those. Well, first and foremost, how many ways can we do that? And that's a pretty straightforward calculation. We got 9 possible choices for the first number, then 8 for the second number, and then 7. And then you multiply it to get the total. And that's 504. So there's 504 different possibilities of how 3 numbers can be chosen. Correct? Now let's turn our attention to the condition that when you do choose those 3 points, those points have to lie on the same straight line. So for example, one possibility is 1, 2, 3. If I chose 1, 2, and 3, do those lie on the same straight line? Yeah, they do, right here, like that. And then similarly, 4, 5, and 6, if I use that, that would also work. That also lies on the same straight line, and so does 7, 8, and 9. And then going down like that, I can also get a few more combinations. I can get 1, 4, 7, right? Those lie on the same straight line. I can get 2, 5, 8, like that. And 3, 6, 9 also lies on the same straight line. And then there's 2 more. There's diagonals. If I choose 7, 5, and 3, that also lies on the same straight line. And of course the other diagonal, like that, 1, 5, and 9, that also will give me 3 points on the same line. So I've got 8 out of 504. But 8 out of 504 is not one of the answer choices, so what am I doing wrong here? Now this is a great question because you're not doing anything wrong so far, you just are not understanding that this is not representing just one, it represents many. And I say, well, what do you mean by that? Many, I don't get it. All right, let me explain. So first and foremost, how many did we create? We created 8, right? 8 that you are convinced all lie on the same straight line. No problem. But each of these, and I'll concentrate on just one, each of these can be chosen in 6 different ways. And let me explain. You got 1, 2, 3, right? But what if I chose 1, 3, 2? It's the exact same set. It's just written in a different order. Or what if I chose 2 first, and then I chose 1 and 3, or 2, 3, 1, or how about 3, 1, 2, or 3, 2, 1? All of these represent the same 3 numbers. They're just the order is different. And even though the order is different, it doesn't matter. If I take any of these and plot them, it would end up on the same straight line. So each of these 8 really represents 6 each. So the total is 8 times 6. That's the number of different combinations. So you take this guy and divide it by 504 to get the probability. So let's do that. 8 times 6 divided by 504. And this is 48 over 504. And let's see here. Does this divide top and bottom? Let's see. If I divide by 24, I'll get 2 on the top. And on the bottom, I'll get 21. So this is definitely in lowest terms. And let's see. Number 5, that would be C. Bertha has 6 daughters and no sons. Some of her daughters have 6 daughters, and the rest have none. Bertha has a total of 30 daughters and granddaughters, and no great-granddaughters. How many of Bertha's daughters and granddaughters have no daughters? So we have Bertha as the top of the family tree, and then she has 6 daughters. 1, 2, 3, 4, 5, 6. All right? And then each of those daughters has children, and we don't know the exact distribution yet. But we have one important clue, that Bertha has a total of 30 daughters and granddaughters. Well, we already know that she has 6 daughters. That's given in the question. So of these 36 are daughters, so that means the granddaughters must be 24. Correct? Because she has 30 daughters and granddaughters. We are told that she has 6 daughters, so the remaining 24 must be her granddaughters. Okay, so this part of the family tree, there's got to be 24 girls because they're all granddaughters. But we want to know, what is the distribution? How many go here, how many go here, and so on, right? Well, an important clue is that some of her daughters have 6 daughters. She has 6 daughters, and some of her daughters have 6 daughters. So if they have 6, say 6 here, 6 here, 6 here, and 6 here, that adds up to 24. That's the only way I can make this fit. And then the rest have none. So this is 0 and 0. Got it? So this is a daughter like that. And then 6D, 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 0 and 0. So this is the way it's distributed. Now let's figure out what is it that they want us to answer. How many of Bertha's daughters and granddaughters have no daughters? Okay, so first let's see how many of her daughters have no daughters. Well, it's this one and this one, because you see, they had 0 offspring. So that's 2. Now, how many of her granddaughters have no daughters? Well, all of them. There's nothing here. It says that she has no great-granddaughters, so this next generation is 0. Correct? So how many of those granddaughters have no daughters? Well, 6 plus 6 plus 6 plus 6, which is 24. So in total, it's 26. 6 is therefore E. It's a little bit confusing, but it's actually not so bad. Just take your time and read the question carefully. A grocer stacks oranges in a pyramid-like stack whose rectangular base is 5 oranges by 8 oranges. Each orange above the first level rests in a pocket formed by 4 oranges in the level below. The stack is completed by a single row of oranges. How many oranges are in the stack? So first, we've got to draw a shape that kind of resembles a rectangular kind of box, I guess, like that. And they tell us the dimensions in terms of oranges. It's 5 and 8. So basically what that means is you've got these oranges in here. So something like this, we've got basically 5 by 8 rectangular base. And I didn't fill in all the oranges, but you get the point. And then basically what they're saying is that when you start the next row, each orange is going to sit on a pocket formed by 4 oranges below it, like that. So let's draw the orange on the second row. but I'm going to use a different color, otherwise it's going to get quite messy and quite impossible to understand. So the second row, it's going to come like this. This is my first orange. And then the second orange, basically concentrating on that sentence that each orange rests in a pocket formed by 4 oranges below it. So like this. And if you keep doing that, you'll get to the end there, and you'll notice something very interesting. It's 1, 2, 3, 4, 5, 6, 7. All right? And how many rows do I have? In each row I've got 7. Well, it looks like I have probably 4 rows like that. So I hope you can see this. I hope it's not too abstract or messy. So let's make a list. We've got row 1, or actually a better word to use, they're using rows, right? I'm going to use level. The first level, which was the oranges I wrote or drew in orange, I had 5 by 8. So what's the total? Well, that's 40. In level 2, the oranges that I drew in green, those, how many did I get? I had 1, 2, 3, 4, 5, 6, 7, and 4. So 7 times 4. And that is 28. In level 3, they'll basically be very similar. It'll be 6 times 3. Because if you drew them exactly the same way, you'll see that there'll be 1 less in each row and 1 less in each column. And that is 18. Level 4 is going to be 5 times 2, which is 10. And then level 5, it'll be 4 times 1. It'll be a single row. Just 4 oranges in a row, and that's 4. And that's exactly what they tell you. The stack is completed by a single row of oranges, and that's what this is, a single row of 4 oranges. And they want you to figure out what is the total. So you just add 40, 28, 18, 10, and 4, and you'll get 100. So number 7, the answer is C. A game is played with tokens according to the following rule. In each round, the player with the most tokens gives 1 token to each of the other players and also places 1 token into a discard pile. The game ends when some player runs out of tokens. Players A, B, and C start with 15, 14, and 13 tokens respectively. How many rounds will there be in the game? So we have player A, player B, and player C. And at the very start, they've got 15, 14, and 13 tokens each. All right, let's go through the rounds. I'm not going to go through all of them, but enough so that you can see some sort of a pattern, and then we can extrapolate. Okay? So round 1, the player with the most tokens gives 1 token to each of the players and also places 1 token onto a discard pile. So if that happens, he drops down to 12, this goes up to 15, and this goes up to 14. Okay, now I'm going to keep a running total here, total number of tokens. And if you do, you'll see that when the game first started, you had 42. After round 1, you're down to 41. Round 2, B now has the most, so he's got to give up, he or she has got to give up 3. So he's going to drop down to 12. A will go up to 13, B will go up to 15. If you add this, it's 40. Round 3 in a very similar way, 12, 13, and 14, following the same rules that I did for the previous 2 based on what is given in the question stem. This drops down to 39. I'm going to do just about 3 more. And this basically drops down to 11, goes up to 14, goes up to 13, this is 38. And then 5th round, this drops down to 11, 12, 14, this is 37, and 6th round, 11, 12, 13, and this is 36. All right, so it keeps on going like that. Now notice one thing. In each round, I want you to notice who has the least. I'm going to circle that. In round 1, it's A with 12. Round 2, it's B with 12. Round C, it's C with 12. And then round 4, the lowest is 11. Round 5, it's 11 and 11. So that means that every 3 rounds, the lowest goes down by 1. We want to get to a point, some round, where the lowest is 0. Why? Because that's when the game ends. The game ends when some player runs out of tokens. And we want to know when it first happens, because it's going to happen 3 times, right? Because 12 happens 3 times, 11 happens 3 times, but we're interested only when it happens first time. That's when the game ends. Okay, no problem. Make another table here that will solve that dilemma. Round and lowest. Now, this table, it's going to end when we get down to 0. We want to know what is that round number. And hopefully we can see some sort of a pattern. So here we go. In round 1, the lowest is 12. Correct? In round 4, the lowest is 11. I jumped rounds 2 and 3 because they also have the same lowest number. And therefore, since every 3 round it goes down by 1, on the 7th round, the lowest will be 10. All right, so I hope you're convinced of that. And then similarly, there'll be around 9. There'll be a lowest of 9, a lowest of 7, 8, 7, 6, 5, 4, 3, 2, 1. And the round numbers are going up by 3 every time. So this is 10, this is 13, this is 16, 19, 22, 25, 28, 31, 34, and finally 37. There you go. So in the 37th round, the player who has the lowest will have 0, and that's when the game ends. So number 8, the answer is B. In the figure, EAB and ABC are right angles. AB is 4, BC is 6, AE is 8, and AC and BE intersect at D. What is the difference between the areas of ADE and BDC? So in this diagram, let's concentrate on the 2 triangles, but they want you to figure out the difference between the areas of these 2, right? ADE, right here, and BDC, which is right here. Now, I'm going to separate this into 3 regions. I'm going to call this triangle A, or the area A, and then call this area B, and this area C. And then triangle ADE, subtract from it triangle BDC. That's what they want us to figure out the difference, this word. So, before I get into the numbers, what is it in terms of length times width and all that, right? I'm going to draw that in red. ADE is right here, ADE, that triangle. But it is part of this bigger one, ABE. It's basically triangle ABE minus this guy here, C, like that. All right? And in a very similar way, triangle BDC, this guy right here, BDC, is basically triangle ABC, basically, the big one, minus ABD. And then let's start using our letters to make things a little bit easier for us. ABE. ABE. I can actually use my numbers to figure that out. I've got enough. So it's 1/2 base times height, but the base is 4 and the height is 8. For ABD, which is this guy in here, that one I don't have the height, right? But that's okay, I'll just put C, which is what I called it. For ABC, I've got the height and I've got the base, so I can figure that out. That'll be 1/2 base times height, which is 4 times 6. And then ABD, it's the same guy again, and I'll just put C, like that. All right, so here we go. 1/2 times 4 times 8 is 2 times 8, which is 16, minus C. And then 1/2 4 times 6, 2 times 6, which is 12, minus C. So this becomes 16 minus C minus 12 plus C. The C's cancel, and I just get left with 16 minus 12, which is 4. And there you go. You got yourself the answer. And number 9, therefore, the answer is B. Coin A is flipped 3 times. Coin B is flipped 4 times. What is the probability that the number of heads obtained from flipping the 2 fair coins is the same? So we got coin A, and we've got a coin B. And the first one is flipped 3 times. All right, no problem. Let's figure out what is the possible outcomes. You can have 3 heads. You can have head, head, tail. You can have head, tail, head. And you can have tail, head, head. All of these have 2 heads, like that. And then you can have one head basically in the form of HTT, THT, TTH, like that. That'd be one head, one head, one head. And then you can have the 0 heads by having all tails. Okay? So this is 8 ways. Now let's turn our attention to B. B will have a few more because B is being flipped 4 times. It's going to have a few more possibilities. You're going to have H, 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 which is 4 heads. You're going to have 3 heads of the following type. You can have 2 heads, such as H, H, T, T. You can have 1 head of this type, H, T, T, T. And finally, you can have 0 heads if they're all tails, like that. Now let's get to the heart of the question, which is, what is the probability that the number of heads obtained from flipping the 2 fair coins is the same? So what do they mean by that? They mean, for example, if I flipped A and it turns out like this, I want to flip B so that it has the same kind of outcome in terms of the number of heads. Got it? Because this has 3 heads, that has 3 heads. All right, so how do we do that? So you do that as follows. Let's first concentrate on the scenario of 3 heads. How do we get 3 heads from A? Well, there's only one scenario. That's if all 3 of them are heads. So out of the 8, there's one way of doing that, 1 out of 8 ways. Now, for B, what's the total number? Well, total was 16, correct? Now, how many ways of the 16 can I get 3 heads? Well, it looks like this guy, this guy, this guy, and this guy. So there's 4 ways. So it'll be 4 out of 16. And I have to multiply those because the probability of getting this and the probability of getting these guys, it has to be multiplied because it's an AND question. Okay? So in a very similar way, let's do 2 heads. Now, 2 heads from this scenario over here, there's 3 possible ways. So I've got 3 over 8 for 2 heads. And then over here, I've got, let's see, 1, 2, 3, 4, 5, 6 ways. 6 ways of getting 2 heads. So 6 over 16, and again, I've got to multiply it because it's an and. Now, what about these guys? Do I multiply? No, I add. Why? Because it's an or. This or that. Remember, in probability, if it's and, you multiply, and if it's or, you add. All right? Now let's, in a very similar way, look at one head. One head over here is 3 out of 8. And one head over here is 4 out of 16. And finally, 0 heads. Over here, there's only one possible way of getting that out of 8. And over here, 0 heads, again, only one possible way, so 1 out of 16. So there you have it. You've got this big long thing, so we've got to figure this out. The good news is the denominator looks like it's always the same, 8 times 16. So numerator, 4 plus 18 plus 12 plus 1. And that looks like 35. 8 times 16 is 128. And I think that's in lowest terms. 35 over 128, perhaps. So let's see, 35 over 128. Great, it's one of the answers. It's choice D.